Well, good morning, and thank you so much for joining me in my shop here. It is, what day of the week is it? I think it's Tuesday. It's Tuesday, August 22nd. What happened? Well, nothing happened. Last few days I was on vacation out of my shop here up in Ottawa, in fact. Ottawa is the capital city of Canada. Beautiful city. If you're in Canada, you haven't been to Ottawa, plan a trip and go there. Okay, so I think there's only two, if I remember right, because it has been a few days, two capacitors left in here. Two that are worthy of changing. I think I'd like to find out which capacitors those are on the schematic, what they're doing before I change them out. So if we look here, just turn up these lights a little bit. So this one's connected to two tube terminals. It's probably pretty easy to figure out which one that is. This one, well, one of the leads goes to this trimmer capacitor, but I see this is connected here, is connected to a wire, is connected up here, and this wire is bare. This is probably the B minus point, but I'm just guessing right now. Okay, well, let's start with this guy. He's hooked up to the tube, to this tube, which is the 12SK7, which is the IF amplifier. So he's on pins number 1, 2, looks like 3. That would be 8, 7. Looks like 3 and 6. There's also a resistor hooked up here too. Okay, pins 3 and 6 of the 12SK. Let's see if I can find that on the schematic. Okay, that capacitor is connected between the suppressor grid here, well, and the screen. So the suppressor grid is really kind of a connection to B minus. So I think that's the way to think of it. It's a capacitor running from the screen to B minus. Here's the screen connection, screen terminal, and yeah, right there. So I mean, they've just connected it physically over here. On the schematic, it's just showing, differently. So that's what that is, 0.05, and its job certainly is to quiet down the screen, to remove RF from it or something like that. So there's to decouple the screen. Okay, that's a pretty important one. Let's go after this one first, and we'll see what kind of. I wouldn't really expect any improvement in the operation of the radio unless this was so bad that I think you would start getting maybe oscillations or something in here, which I don't think we're having. But anyway, let's go after that capacitor first and see what happens to the radio. Okay, might as well cut it out and give it a test right away. Yes, the weather here today in Aurelia is fantastic. It's not hot. It's going to be sunny or semi-sunny. It's going to be like that for days to come. It has something to do with a blocked weather system in North America. I think the same system that's driving cool air into my area is holding very hot air throughout the United States. Central United States right now, and people are cooking. And once again, the weather here is really nice. So how lucky am I? Very lucky. There's so many people suffering all over the world, especially here in Canada with the tremendous forest fires that are happening. They're propelling people from their homes, and sometimes entire communities are having to I was going to say head for the hills, but it's really quite the opposite. It's head away from the hills. Some of these communities are very remote, so to go somewhere means to travel a long distance. A long, long distance. Okay, let's see what 50 volts does on this capacitor. Here we go. Well, it's closed right up. Okay, so they don't get much worse. Nice looking. It has a nice look to it, but so much for that. Let's put it in the heaping pile of dead soldiers there. I shouldn't even say that, should I? Because there's some soldiering going on in the world. Yeah, just so much. So many things I really didn't expect. And I'm sure it's true for you too. Okay. I gotta put another one in there. Okay, that's what I'll do. I'll stop and put it in there. Because I'm rusty after a few days vacation. Oh my gosh, it's already coffee break time. I've only started here. Off to a late start. Okay, I'm gonna plug them in. You have replaced that capacitor underneath there. I'm gonna switch on. I'm gonna apply the power. Gonna be through the dim bulbs, of course. Everything seems fine. Here we go. Go to the station that we've heard most of the time. That's interference. Well, I wouldn't call that any better, that's for sure. And I don't think it's much worth going any further. We just check to make sure the radio is still operating, which it is. Okay, the last capacitor, the last man standing, this guy here. Let's figure out what it is. So again, I think it's just going to ground here, or to the B minus, but I'm not totally sure of that. And the other terminal, or the other wire on the capacitor, is going to a terminal here. I've already replaced two capacitors, three capacitors to here. And you know what? I can see this. Oh, wrong terminal. This terminal is going down to the chassis. It's this other terminal. Yeah, this capacitor lead wraps around, reaches this terminal. And there's a red, green here. So it's 2.2 megohm capacitor resistor. Should be easy to figure this out. Let's find out. Maybe hunt down this resistor is really the better move. I think there's only one 2.2. Let's have a look at the schematic and see. There's a 2.2 right there. Is there another 2.2 resistor in here? I doubt it. 4. 1. No, there won't be another one. So this is the resistor. And at one end is a capacitor. I think I already changed this one. So this might be the one here. I know I got confused when I was doing these two capacitors about which was which. So basically, maybe what I should say is that one of these two is left. How can you tell? How can you tell which is which? Well, one of them goes to the B minus, and the other one doesn't. Okay, I think it's this one. That's a super important one. Why would I have left it to the end? Just out of confusion, I think. Okay, let's do it, regardless of which one it is. It's this or that or this, and we'll do it and see what happens here. 0.05. Okay. 0.05. What kind of voltage? Not much voltage. Not much voltage here. Okay, that's good. Chop them out of there. pretty dried up. He's a sorry looking fella. But considering how the other ones have tested, can't expect anything other than pretty much a lousy result on this. But let's see. Okay, here we go. 50 volts. It's trying to open, but it's not even opening. So, you know, as capacitors go, these are bad. These are bad. Very bad. Not shorted. They're not opened. They still have some capacity, but very leaky. On the basis of, I guess you would say, a qualitative comparison between capacitors coming out of all these radios. Those ones rank as about as bad as they come. Okay, so we're going to put another one in here and operate the radio, and that's it for capacitors. At least the big wax ones. Okay, got the new capacitor in here. Good, it's good. Let's try it one more time. Then all that really remains here to consider with this radio is alignment, I think. Here we go. Dim bulb's good. I might have turned the voltage down here. Let's just see what it comes up to. 100 should be enough to make it make the radio work pretty normally. We're going to go a little higher with it. Still warming up, so the current drain is changing there a little bit because I'm still feeding the power through the dim bulbs. So you can hear I can hear it anyway. The radio getting louder as I turn up the voltage. This is slow to react. Okay, let's check it out. What do we got? Lots of interfering noise. Pretty sure there's a station right there. Yeah. But we're not going to hear anything much more than that. So again, the radio's operating. I didn't mess it up changing that part. And we've got no wax capacitors left in this radio. But what we have is an alignment process that I think may make a big difference, because I've only done kind of a roughshod approach to that so far. Okay, so what we'll do is we'll start with aligning the IF properly to well, to what? To what? Probably, yeah, 455. Let's see, signal generator output. Use a 200. Use a small capacitor in the antenna line to help the radio feel like it's hooked up to an antenna. I guess that's what you're saying, to the antenna, right? Signal generator to antenna. To antenna, 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 antenna. Every time it's to the antenna. What do they mean by that exactly? So on the back here, there's a wire hanging out, which is probably the antenna wire. Could make that assumption. I find out pretty quick probably by just hooking up the signal generator and seeing how it goes. Now another way is to feed the signal into the loop antenna using another loop held up close. But they say hook it up with the capacitor, and I guess that's what we'll start with that. And why wouldn't that be the antenna? What else could that be? This wire comes in, loops through nothing more than a support here, It comes right back out. This is the same wire. Here it's connected to a capacitor. There's already a capacitor here. And then from there, it's right onto this antenna coil. I guess you'd still want to add another capacitor out here to make sure whatever's beyond this wire is imitating an antenna and not being what it really is, a signal generator with a very low impedance. That's no big deal anyway. Definitely that's the antenna wire. Okay, let us do that. Okay, let's run over the setup here before I get going. So this is the output from the signal generator. There's a small capacitor in here that should do the job. And you want to connect this. Where do you connect the negative? Or the ground? Does it actually say? I don't think it's going to say output. I don't think it says anywhere here. So probably B minus, rather than the chassis. Well, you might be able to get away with hooking it up to the chassis too. No word here is set, so we're going to go on the B minus. We're putting basically a power system ground. Like this is plugged into an isolation transformer, but as soon as I connect this, then there is a ground associated with the radio from then on. So I'm going to put this on the B minus, and I won't say any more. I'll just say that. I'm going to want to lay this down. I'll lay this down. Can I get at it here? Maybe from this end. There we go. Okay, then this is going on the antenna. There we are. Oh, I haven't turned on my signal generator yet. We should have that on. So I've used this enough now. I certainly have a notion as to how strong its output is and what a radio should be doing in receiving a certain strength of output from the signal generator. Just on a sort of a qualitative basis. So we want the output frequency to not be 1,000,000, but to be 455. We'll just put it there for now. So this is set for 1,000 hertz of modulation, but let's set this here. I'm going to calibrate. Not that we really need a calibrated output, but why not? Okay, so 1,000 hertz tone. This is a very low signal, so I'm going to snap it up a little bit. That should be enough to be heard in the radio. We will see, though, what happens. Of course, not at 3. Whoops, I just changed this. Not at 366. We shouldn't hear anything. And I have this meter set up to monitor the AVC voltage. We're going to set this to 30 volts, and we're going to set it negative. And we're ready to go, I think. Okay, so we're going to apply the power gem. Okay, switch is on, volume's down. Here we go. Yeah, nothing happened. Good. Let me just turn off my soldering iron here. Now, during this, they like you to have this tuned at the high end. So the capacitor open. There we are. So we've got a negative voltage has appeared. Let's tune around just a little bit and see this move. Excellent. So what I'm going to do is I'm going to get that to go down as low as I can get it. This indicates the least amount of signal coming out of the IF. Right down there, right there. That's going to be good enough. Okay, now I'm going to tune the signal generator. Come on over here. I'm going to tune the signal generator and see where we end up. .366. 455 is where we're going. I didn't hear a thing. this up. I got something wrong here? I don't think so. Okay, well, I've only got one more step up to go. Ooh, now we hear it. Can you see what number's showing up here? 430. Okay, watching the meter peak. 433 is where the IF is tuned. That's a fair bit off. The funny sound we're hearing, I'm not sure what to make of that. Let's just go up 455. A little something there, but who knows what that really is. And something way up here at 500, close to 500. Well, I'm not sure what to make of that. Okay, let's go down. Wow, am I doing something terribly wrong here? Because those two numbers are weird. The whole thing is weird. Well, let's give it a go. I mean, I did just tune this by ear, and there's no guarantees of success here. I don't know if this is going to work out well. This light down there. So I want this meter to go up. We'll start with the most sensitive one I discovered last time. This adjustment was the most sensitive one. So we're still at 433 on the... Well, it certainly does seem to want to tune into this. We'll put this up a bit, see if we can find it. Yep, go right by, turn this up. Still 433. Something funny going on here. There's something funny going on here. Funny haha. What could be going totally cockamamie wrong here? I don't know, to be honest with you. I don't think anything could be going cockamamie wrong. Maybe I'll have to try something entirely different here. So usually what I do is I find out what the frequency is that the IF is actually centered on, and then I just move it from there, but hearing it the whole time. Because if you don't hear it, you can't tell where it's moving. And you can move it all into the wrong direction. This didn't seem to move at all. Let's try a couple more capacitors here. So we'll put this up 440. That's in the direction I want to go. That's a little louder. Distortion is... Oh gosh, I don't know. What's going on? Certainly not getting what I expect. What's the modulation set to? So modulation's at 30%, which is where it should be. We should hear a nice clear 1000 hertz tone coming out of this radio. Is this thing just so far out it's crazy? To think here, because it says noise signals are also moving through, coming out of the IF and causing the meter to move too. As I adjust the tuning of the IF, the radio starts picking up other stuff. So we're just watching this now. Very interesting. That's close to 455 there. Well, I can hear it at 455, so let's put it at 455. Try to tune it up. Just ignore the noise at the moment. The garbling. Okay, just do a manual sweep through here. Oh, see, there's something happening here. Again, that's the 455. 433 is gone, so I've moved that. So it would seem like we still have one more way up here. Way up where? Here. What I'm suggesting is one of the 4 coils is tuned up around this frequency here. And which one would it be? Who knows? I don't know. We got to do something a little different here. I'm not getting a great feeling out of this. I think there's more going on than meeting the eye at this point. Okay, I'll set up a different approach to doing this. We'll see if we can learn more about what's happening inside the radio. Okay, in the midst of connecting up some new equipment, I was just going to connect the scope lead ground to what I believe is a B- lead coming out of the radio. I get this. This is suggesting to me that I don't have the signal generator hooked up to B-. I've hooked it up to something else, the ground side of it. So I'm just going to relocate the signal generator lead. This might explain a lot of things, why I was having trouble. I picked a spot that's not really a B-. Well, you know what? I can just go on this clip lead. I just go on this B- clip lead out here. I didn't have to. Let's turn it back on. See if that sounds any different. And it does. So I may have hooked it up to the chassis. That sounds a lot better. Okay, that was probably the problem here, was what I was doing. Yes, go back to continuing to use the single frequency signal generator. See what's happening now. We're way up at 475. Well, it sounds a lot better to me. Except for this guy. What's he doing up here? So we're going to go to 455. Very good. And we're going to adjust the radio and try to make this meter go up higher again. Who's way out? Can't be this one. This one was the one that was very sensitive. I don't think it's this one. I don't think any of these. One last one. This one's cranked down really tight. Yeah, there just seems to be one spot. So I'm hoping one of these will suddenly identify itself, but it has not. Okay, so let's just see if that other tone is still there. Sure is. 475. Okay, I'm going to go back to what I was going to do, which was set up a sweep analysis of the of what's going on here. Yeah, I'm almost there now. Right, I was just hooking up the ground to the scope when I discovered what was going on. There, see, I can hook up another ground. I'm going to hook up the scope to the same place as the meter here is hooked up, which is input to the volume control, where the detected DC voltage or ADC voltage is sitting. Please connect. There we go. Right, this is on the times 10 input. Okay, now it's going to take a moment here to get this all going properly. First, I want to set the scope to receive its sweep signal from the sweep generator here. There it is. We turn the sweep on. There it's sweeping. Make sure we have the sweep sensitivity correct. About like that. Center it up fairly well. The entire sweep from here to here. This represents a range of frequencies. Okay, looking up here at the numbers up here. The starting point is 400 kilohertz, and the stopping point is 510 kilohertz. Right in the middle is 455. Okay, the sweep is back on. Now, we're not seeing any result from the vertical yet. Because I have this set very insensitive. Turn that up. Now we got something going there. Not supposed to look like that. Sweep speed. Basically a lot of audio in here. Let's put this on DC. Put this back down. Okay, so at this point I'm going to stop, drink some coffee, sort out why this isn't working quite right, and then when I get the video going again, we'll watch. What we're looking for is a response curve in here. That's what we're looking for. Okay, let me just turn down the radio a bit. So what I've got right now is I've got the oscilloscope and the voltmeter hooked up to this point here, input side of the volume control, which is basically the output of the detected or rectified IF signal here. So right here is a combination of some DC that is built up and the audio signal. And when we look at the scope, we're seeing a sine wave on the scope. It's the audio signal, which is present here. I don't really want to see the audio signal. What I want to see is the variation in the DC voltage that is coming and going here. And we know it's happening because the voltmeter is showing it, was showing it. If I want to get away from the audio, I could go to the other side of this resistor. Over here, the audio is being snuffed out by these capacitors, maybe this one in particular. And what should be here is a fairly straightforward DC voltage. And the voltage will get greater and lesser based on the output from the IF. So we get to monitor the strength of the IF by looking at the ADC voltage here. Problem with putting the scope here is that this is a high impedance circuit. Very, very high impedance circuit. So any little finagling can have an impact on the radio. So we'll have to check for that finagle impact if I'm going to try this. Other alternative? No easy other alternative, I don't think, offhand. So unless I try to use an RF probe, it might be a good time to experiment. I have a few of them now, RF probes. Might be interesting to experiment with them. So an RF probe, it internally rectifies the RF, turns it into a DC voltage that you can display. So that's another way. That would be almost like bringing your own detectors in, your own detector, a separate detector. Could try that. But first, why don't we go to the other side here, and we'll do the sensitivity test and see if it throws a radio way off. I also have my scope input can be switched from times 10 to 1, which changes the input impedance or the load on the circuit quite a bit. We can experiment with all this stuff and see what happens. Can we find a good spot? Can we find a good spot? Now, this is way down here because the DC is driving it down. Okay, so back up a little bit. A little hard to see the scope at this distance, but we'll disconnect it here and reconnect it. Oh, well, that resistor is under the chassis. Okay, something I don't normally like to do is lift these radios while they're operating. And, I'm not going to do it. Turn this off. No harm in turning it off for a moment. Okay, there we are. Turn it back on. Okay, take this off here. Can we get it around? Ooh, wait a minute. We're losing everything here. Okay, we want to try to move the scope. I can't possibly do it like this. Move the scope. And watch out for flying clip leads here. Okay, good. Okay, first we want to put this on the B minus. Same place as this clip lead. These long clip leads I'm using too, they can be causing problems themselves. It's like hooking up big antennas. Ooh, if I just hit this the wrong way, boom, I'm going to short that capacitor out. I'm going to get a big pop. Even if I turn the set off. Yeah, this is a little, maybe there's a better spot. Where's a better spot? There certainly are better spots. I don't know where they are offhand. So here's the big resistor. The other side is worth being sure about. There's that big terminal right there. And the ground, within range of this. It's very attractive to put it up there. Okay, let's just turn the power off. If I do short the capacitor, then it's just one nice pop. I'll try to attach this here in some kind of decent way. Shield your eyes. Okay, that's good actually. And then we want this to go on the other side of the big resistor. Well, we're going to want to touch it and stuff. Okay, power on. Okay, you can see the voltmeter go up. A lot of scratching. Okay, what happens? I touch it here. Oddly enough, we get an improvement. Okay. Oh, maybe this is the far side. There we go here. So you can see on the scope, a little hard to see, I know, but the sine wave showing up. And on the other side, no sine wave, just a DC voltage, so this is perfect. So we're going to go here. I'm on the, well, that was the times 1. Let's put it on the times 10. Because now it's having no effect. You can still see the scope is moving a bit. Perfect. That's perfect. That's perfect. Now, the other thing is we got the wrong input. We have a single frequency input. Let me turn this down. We have have a single frequency generator input, and we want to put in the sweep input. So I'm just going to simply move this lead here. Actually, I'll take this whole. I take this one here. Take this off. Swing it around. And hook it up here. Boom! The sweep is a sweeping right now. Sweep is sweeping. What do we hear? We should hear a bzzz. Good. That's good. That's the sound of the sweep passing through the tune point of the IF. Okay. We've done it. Let's see what we get on the scope now. Not much. Not much yet. Center it up. More sensitive. More. Okay, so it's flowing off the screen because I have it on DC. We'll bring it back onto the screen. We'll try to bring it back on the screen. There it is. Oh, we're getting a really weird shape here. You can hardly see it, but there's just a little bump here. It doesn't look right. Flip it to AC. Gotta bring it back into the center. Looks the very same. A little. This is a terrible looking thing. So I think the jumpiness, some of that is the interference. I'm going to tune the radio a bit. Each time the DC voltage changes, the scope will fly off the screen until the scope's own capacitor charges, and it'll come back in the middle. See that jumpy stuff? I'm not sure I can get rid of it all. Okay, now we got almost no, you know what? We've got almost no input signal. That's what's happening. We've got almost no input signal. So we're going to make this much less sensitive. The jumping will stop. And we're going to juice it up. Down on the volume completely. There we are. So this is a lousy curve we're getting. Now you can kind of see it. I can make it a little bit bigger. It's not supposed to look like this. This is not supposed to be here. This should be a nice curve. Or maybe the other way. Maybe, I don't know. That's very strange looking. Once again, have I got something hooked up wrong here before I start fiddling? Why would it even look like that? You got me. I've done this quite a few times. A mixture of good success and not so good success. Kind of just depends on everything. Kind of depends on a lot of things, that's why. Okay, well the next thing to do would be to fiddle with the tuning. Oh, who's loose here? Who's jumping around? Just step back a little bit here. I think we'll be better off. I don't know who is loose. Somebody's loose. Swing this all the way around. Careful there. Careful, man. Okay. We can start doing these. Scope's a long ways away in the camera, I know, but... Oh my god, this thing's gonna move. Okay, I'm going to stop. I'm going to put a better camera on the scope so you can see in detail what's happening. I think that's going to be important. And also I'm going to try to find a way to lay this down safely, so because I don't like it the way it is. And I'm going to go drink some coffee. Coffee is probably the most important part. Just to keep telling the story every step of the way. So I decided, well, now I've got a fairly decent display. It's different now, by the way. Why don't I try hooking the scope back up to where I originally had it, which is just the same place as the voltmeter. So I've done that, and I have an even better display now. By the way, the brilliance you're seeing for this is the camera changing. Sometimes it's much brighter momentarily in that. That's the video camera changing because of the average light levels in my shop. So this means I can lay this set down again quite safely. as well just leave it. Famous last words. Wait a second here. I can also move this ground out. Pretty sure. We'll find out momentarily. I've got the same display. Whoops. Yeah, all these clip leads, this can all cause unwanted problems with doing this kind of measurement. Okay, power back on. If you notice, the dim lights didn't flash at all, and that's because the power supply capacitors didn't discharge during that time. Okay, we've got an excellent display on the oscilloscope. Particularly if I just turn it up a little bit. Might be there. That looks good. You can see that quite clearly now. And we'll just leave it like that for now. I tried to set this so 455 would be in the middle. Can't be absolutely sure where 455 is, but you can see this curve is pretty close to the middle. There's a funny little bump happening there. Yeah, maybe I will put up the... yeah, I think I'll set up the closer camera. Okay, you can see the camera sitting here, so I'm going to flip to that camera and get a close-up of the oscilloscope. And so just a couple things. Look at it, it's very steep here, kind of dragged out there, and this funny little kink right in it, right here. Isn't that just a little bit odd? Let me just check the focus. Ooh, that's brightness. Let me check the focus here. There we are. Okay, what I'm going to be doing is I'm going to be tuning the trimmers in the IF cans. I'm going to start with the most sensitive one and just see what it does. So here we go. So I'm moving the most sensitive one. I'm going to try to make the curve go down as low as possible. The strongest curve possible. Now next trimmer, you can you tell I'm actually moving 4 response curves and trying to get them on top of each other is really what I'm trying to do here. So if I move one of them, you can kind of see it sneak. You can imagine, you have to use your imagination, that it's moving back and forth. There, you can actually see it now. You can see it over here. So I'm going to line it up with the other one. The assumption being that they're kind of falling into the 455 spot, although we can't be absolutely sure. Okay, that was one transformer. Now I'm doing the other transformer, primary and secondary. So the kink disappears. This kink, I can make it disappear, or I can bring it back. You know what that is? That's that other signal I was picking up, or it was responding at. That's another response location. Let's make it disappear. Okay, and then we'll maximize the bump with that disappeared. Okay, last screw of the 4. Oh, look at that, come back. The kink really came back. So this one transformer is introducing a kink, or a second resonant location. Why? I don't know. So I'm going to tune this so it's not there. It's very minor, though. I would think you might not have any influence on the operation of the radio at all. There's my ghostly image there. Hello. Well, now we need to know, is this 455 or where did we end up? So to do that, I'm going to introduce the other signal again from this signal generator. Just get another cord. And I'm going to input this into the antenna right in parallel with the sweep generator. Kind of a clumsy way of doing it, but that's what I'm going to do. So first we are going to attach to the multi-grounded star point here I've created. star ground. Okay, and we're going to turn down the output. So both signal generators will be feeding into each other, but I don't think it's harmful because these are not super powerful signals. Okay, now I'm going to look back. I'm going to put you back on the other camera. So the idea here is the single frequency generator will cause an interference to this curve that we can see. So I will attempt to make that happen. We need a little more juice, more juice, more juice. Okay. Now let me just move it around a bit. Okay, it's doing the thing. This is kind of subtle to see. In this case, maybe because the sweep is up a little high. I turn the sweep level down a bit. The two signal generator, my single frequency signal generator is at its maximum output, so I reduce the other one to make it more fair. It will tune back and forth a little bit. Okay, now if you look at the curve right here, you see a squiggly thing happening. You can kind of imagine the center of the squiggle might be right where my stick is right now. And I'm going to change the single frequency generator. The squiggle is going to come down. And if we get it to stop right at the bottom here, you can see it quite easily. So here we go. Okay, so now the single frequency signal generator is right on that dip. I am now going to show you what the radio IF is actually tuned to. And it's surprising. 473. We missed 455 by a mile. We ended up on 473. Oh my gosh. 455 is... Well, let's see if we can find where 455 is on the scope display. This might be a little tricky, but let's see if it's there. Ooh, I just about clicked the wrong button here. Okay, so I'm going to tune down the single frequency to 455 and see if you can keep an eye on where the squiggle went. It's pretty tough to spot. Oh my gosh. I need more. I need less here. Less here. And I've got no more over here. Let's go back. What happens if we get down to 455? Does it do another center squiggle? Son of a gun, it does. Okay, hold on. Okay. So I'm a little wrong in my judgment. Let me increase the sweep again. So what we're finding out is there's still a resonance at 475. So I'm at 458 right now. Go back and forth. You can kind of see it coming through the curve. I'm going to make it stop at the bottom. Because my hand's on the control, I have a big advantage to understanding what's on the screen. So I would say it's at the bottom, right there. So curious things are happening. And what frequency is that? Oh, wrong button again, Jim. Maybe I've been in here too long already today. 457. It's not quite 455, but it's pretty darn close now. But what's that other thing? What is that other thing? So you can just watch these numbers, and I'm watching the scope. Okay, there's something there. Something, actually, this is quite strong right there. Well, there it is, 172. 472. Well, it's an interesting question. What's happening there? How would this affect the radio? This could affect the radio. If you had two response points in the IF, I might have to do this transformer by transformer to eliminate to discover what's happening here. Because I don't think it's satisfactory the way it is. Maybe if the second thing was far away, it wouldn't matter, but it's not that far away. 455, 472. Yeah. And maybe I'm going to leave it right here, right now. This will be the end of it for today. Tomorrow we'll try to nail down what's going on with this IF. Why it has apparently two sensitive spots, two resonances. How can that even be? Okay, well, thanks for watching to this point. We'll just carry on tomorrow. I'm just going to shut everything off and we'll just turn it back on tomorrow and carry on. Thanks a lot for watching. See ya.